Hello, here you see from exercise 1.4, I'm going to question number 3. The question says the following real numbers have decimal expansions as given below. Here they are given. In each case, decide whether they are rational or not. If they are rational and of the form p by q, what can you say about the prime factors of q? Okay, so the first number that is given to us is number 1 is 43.1234 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 8, 9. This is the number. There is no continuation, there is no bar sign. Now see the number 43 point, such a big decimal part. But there is no continuation or there is no bar sign. So it means that it is a terminating decimal. Okay. Since it is a terminating decimal, therefore it is a rational number. Okay. Now you remember two types of decimal numbers are rational numbers. One is terminating decimal numbers are rational numbers, and other one is non-terminating repeating decimal numbers are also rational numbers. This is a terminating decimal number, so it is a rational number. Now since it is a rational number, it must have p by q form. Therefore, we will go for the p by q form. 43.12345678 can be written as 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by, you can write a 10, and after decimal you see how many digits are there. 1 to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Give a power 9. So here it is in the form p by q. In the p by q form. Okay, p by q form. Okay. This is p, this is q. Now the question says, if they are rational and of the form p by q, what can you say about the prime factors of q? Now this q we can also show 43, 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 10. 10 means 2 5s are 10. 2 into 5 whole to the power 9. That means the denominator q has prime factors 2 and 5. Okay. Denominator q has prime factors. What can you say about the prime factors of q? Okay. So therefore we can say that is so we continue here, that is I dot e dot comma the prime factors of, here I have compared to p by q. No, p by q equal to say p by q. This is the p by q form. Q, prime factors of q. Q means here the denominator I. What? 2 and 5. 2 and 5. Okay. The prime factors of the denominator will be 2 and 5. You remember the theorem. A number, okay, a rational number gives a terminating decimal only then when its denominator has prime factors 2 and 5 or both. 2 or 5 or both. Okay. With certain powers n and m, means what is called non-negative integers. Okay. I hope it is clear. Now let me take the second question. Question number 2. Question number 2 is 0.120, then 00, again 12, then 000, again 12, 4 zeros, and continues, and so on, in this manner. So what we understand by studying the number, you have studied this type of numbers in class 9. So we write, since it is a non-terminating, because it is not terminating, it continues, non-terminating, non-repeating. You see 1, 2, then 0. 1, 2, 0 is okay. But again 1, 2 should come, but there comes a 0. So that means the repetition is broken. No repetition. Non-repeating. Decimal. Okay. Decimal. That means since it is a non-terminating, non-repeating decimal, therefore it is an irrational number. Okay? It is an irrational, means it is not rational number. And when it is not rational number, it cannot be expressed in the form P by Q. Since we cannot express it in the form P by Q, so then there is no question of finding the prime factors of Q. Okay? So it is an irrational number. That's all here. Okay. Now let me take the third one. Take the third one. 1, 2, 3. Okay. What is the number? 43.123456789. Like number 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. But the difference is that there is a recurring sign. Means these digits continues. Again they come, all of them come, again all of them come. So that means it is, since it is non-terminating, because it is recurring. It is a non-terminating, but you see, in question number 1 it was not there, so it was terminating. Here it is not terminating, but the same digits are coming again and again. So repeating decimal. Again I tell you that two types of decimal numbers which are rational numbers. One is terminating decimal number, one is non-terminating repeating decimal number. That means it is a rational number. Therefore, it is a rational number. Okay. So that is, if it is a rational number, it has P by Q form. That is, it has it has P by Q form. P by Q form. The form we can write this divided by 1, 2, so 9 nines. But it is not necessary here, 9 nines. What you can comment on Q? What you can comment on Q? That is the question. What you can say about Q? So it has P by Q form, right? But if Q has prime factors 2 and 5, if Q has prime factors 2 and 5, then it gives a terminating decimal number. But if Q has prime factors other than is not of the form 2 to the power n, 2 to the power 5 to the power n, okay, not of the form, so that means, so it has P by Q form, but Q is not of the form 2 to the power n dot 5 to the power m, where n and m, it is not of the form 2 to the power n 5 to the power, where n and m are non-negative integers. That means we can also say, that means it can have other prime factors other than 2 or 5. That means it has prime factors. Let me write one last sentence, that is, it has prime factors. So that is, so therefore it has prime factor other than what is called 2 or 5. Okay, so this way we can come to the conclusion. P by Q form also we can write, but not necessary. What you can, since it is a non-terminating repeating decimal number, so it is a rational number. If it is a rational number, it has P by Q form, where P and Q are integers, Q not equal to 0, etc. But the difference is that Q is not of the form 2 to the power n 5 to the power n, where m and m, you know, that means it has, that means Q has, that is therefore Q has prime factors other than 2 or 5. That means prime factors other than 2 or 5 has a prime factor also, you can say 2 may be there, 5 may be there, but other than 2 or 5, any other 3, maybe 7, okay, or any other prime number may be possible, because it is a non-terminating repeating decimal. I hope it is clear. Okay.